You know, every single time you walk, or wave hello, or even just nod your head, you are using one of the most incredible pieces of engineering in the known universe, your own body. So today, we're going to pop the hood and take a look at the hidden architecture that makes all of that motion possible. Okay, let's get into it.
The entire system really is built to solve one huge challenge. See, our skeleton has to be this rigid fortress, right? It's got to be strong enough to hold us up and protect our most vital organs. But at the exact same time, it has to be this super dynamic machine, capable of an insane range of fluid motion. So the question is, how on earth does it manage to be both? You can think of it as the engineer's dilemma. On one hand, you need the unyielding strength of a skyscraper steel frame. But on the other hand, you need the grace and total fluidity of a dancer. The body's brilliant solution to this puzzle? Well, it lies in a really sophisticated system of connections we call joints.
Now, nature didn't just go and create one type of connection. That would be too simple. Instead, it came up with a whole spectrum, a tiered system where every single connection is designed for a very specific job. And the cool part is, it's all categorized by one simple, elegant idea: just how much movement is allowed. So, here are the three main tiers. First up, you've got the immovable joints, which are all about rock-solid stability. Then you have the slightly movable ones, which offer just a little bit of give. And finally, the big one, the freely movable joints, which are the true engines of all our movement. Let's break each one down. Okay, let's start with immovable, or fibrous joints. The absolute best example is right here, in your skull. You see these intricate interlocking lines? Those are called sutures. They literally fuse the bones of your cranium together to make a solid, protective helmet for your brain. The goal here isn't movement at all. It's absolute, no compromises stability.
All right, moving on to that middle category, we have these slightly movable joints. These are connected by cartilage, and they give us this fantastic blend of strength with just a little bit of flex. The vertebrae in our spine, for example, can bend and absorb shock because of these. And the joints connecting your ribs, they allow your chest to expand just enough every time you take a breath. It's all about controlled flexibility.
And that brings us to the main event, the freely movable or synovial joints. These are by far the most common type in the body, and they are the whole reason we can run and jump and write our names. What makes them special is this fluid-filled space between the bones, and that space is the key to their nearly frictionless motion.
The real secret sauce here is this amazing stuff called synovial fluid. This thick, kind of egg white-like liquid has three critical jobs to do. First, it lubricates the joint so everything moves smoothly. Second, it acts as a shock absorber to cushion any impact. And third, it delivers oxygen and nutrients to the cartilage to keep it healthy. It's a serious multitasker. But, these synovial joints aren't a one-size-fits-all kind of deal. Nope. They come in several brilliant designs, and each one is engineered for a specific kind of movement. So let's take a quick tour of the 5 main types.
First on our tour is the design that offers the most freedom of all, a true marvel of 360-degree motion, the ball and socket joint.
The engineering behind it is just beautifully simple. You've got a spherical ball on the end of one bone that fits perfectly into a cup-like socket on another. This lets you move forwards, backwards, sideways, and even rotate. Your shoulder and your hip are the classic examples. It's what gives your arms and legs that incredible range.
Next up, we've got a much more intricate design. It's deceptively complex, and honestly, it's a huge key to our evolution as a species: the saddle joint.
I want you to imagine 2 Pringles, or saddles, fitting together. This unique shape allows for some really complex back and forth and side-to-side motion. The number one example is in your thumb. And it is no exaggeration to say that this single joint is why we have opposable thumbs. It's the joint that let us build tools and, well, civilization.
All right, our third type is beautifully simple. It's probably the most intuitive design in the entire body, the classic hinge joint.
And yeah, it works exactly like the hinge on a door. It allows for stable, powerful movement, but only in one direction, in one plane. We're talking about bending and straightening. That's it. And you see it working perfectly in your elbows and your knees.
Okay, now for a joint that's all about rotation. This is the one that lets us scan our surroundings with just a simple turn of the head, the pivot joint. The design here is kind of like a peg rotating inside a sleeve. A rounded part of one bone sticks into a ring that's made of another bone and a ligament. The most famous example is right in your neck, between the top 2 vertebrae.
This is literally the joint that allows you to shake your head no.
And last but not least, we have a joint that's responsible for all the subtle but totally crucial fine-tuning of our movements, the gliding joint.
With these, the bone surfaces are mostly flat, and they just slide or glide over each other. This allows for these subtle little movements in any direction along the surface of the joint. You've got them all over your wrist and in the palm of your hand, and they're what allow for that complex waving motion that seems so effortless.
Of course, these joints aren't working alone. They're part of a much bigger system of support. So let's take a quick look at the crew that keeps everything stable and talk about what happens when that system gets put under strain. And this is why understanding this stuff really matters. As we get older, our bodies can produce less of that amazing synovial fluid. At the same time, these sharp little things, called uric acid crystals, can build up and displace the fluid that's left. The result? More friction, inflammation, and pain, the condition we all know as arthritis. You can see the huge difference right here.
So what's holding these joints together in the first place? Well, there are two key players. You have ligaments, which are like these strong, elastic straps that connect bone to bone, therefore stability. Then you have tendons, which are more like tough ropes, and they connect muscle to bone. So when a muscle pulls, the tendon yanks on the bone, and that's what creates movement. It's that simple. Straps for stability, ropes for movement.
And so, when we zoom all the way out and look at the whole skeleton, we see how it all just comes together. It all points to one single elegant principle, designed for purpose. Every single connection in your body, from your immovable skull to your super flexible hip, is perfectly engineered for exactly what it needs to do.
It's just an incredible, interconnected system of levers and hinges and cushions that's working silently every single moment of our lives. It really makes you wonder, doesn't it? What other marvels of biological design are hiding in plain sight, just waiting for us to understand them?